Given a positive integer n, generate a square matrix filled with the elements from 1 to n squared in spiral order. That's about today's video. Let's dive in. San Francisco Bay Area, or Silicon Valley. This is where my dream started. Hey everyone, this is Steve here. Today we're going through another LeetCode problem, LeetCode 59, Spiral Matrix 2. As we have gone through a spiral matrix yesterday, or a few days ago, this one is basically a follow-up, but there is some nuances, a little bit differences. So this one is always a square. So let's take a look at this question first. Given a positive integer n, generate a square matrix. So this is a square, it's always a square. There's no chance it's going to be a rectangular. Filled with the elements from 1 to n squared in spiral order. So its row is a number of n, column is also a number of n. So given input 3, so it's going to generate a 3 by 3 matrix. So looking at here, it's 3 by 3, 3 rows and 3 columns, and it's in spiral order. So see, 1, 2, 3, and then it's not starting from the left side of the second row, it's going down from top right to bottom right. 1, 2, 3, 4, 5, and then 6, 7, and then 8, and then 9. This is the spiral order. If you guys recall the previous LeetCode question, which is spiral matrix, I'll put the link to my other video, basically the first question of this series of questions, spiral matrix 1, 2, 3, down in the link in the description below. You can take a look at that one first. But here, basically the algorithm is very similar. We'll just use 4 variables. Top indicating the top row, and left indicating the left boundary of the columns, and right to indicate the right boundary of the columns, and bottom to indicate the bottom row. And then we'll just keep shrinking from left and right, shrinking towards the middle, and from bottom and top shrink towards the middle as well. The algorithm is very similar to the previous one, but we just need to tweak it a little bit, because this one it's asking us to generate the matrix, right? Not printing it out. We'll just generate it. So we'll keep incrementing the value, the number, and then assign the constantly updated value into the matrix at the correct position. So basically we need to calculate the row and the row index and column index, and then just keep incrementing the value, assign the correct value into this matrix. That's it. There's nothing else we can talk about. We just used basically for loop, similar to the previous solution. Use for loop to go through row, column, row, column. So for loops, and in the outside there's going to be another while loop to control this entire thing. That's it. Then we'll just start coding. First we'll initialize the final result. Call it result new int n and n. So it's going to be a square. So first we'll check corner case. If n equals to 0, we'll just return result. And then we'll just have 4 variables, as I just said, top, bottom, left, and right, to control the 4 boundaries. Int top is 0, and bottom is n minus 1. And then left starting from 0, and the right starting from n minus 1. Then we'll have a outside while loop to control the boundaries, to say left is smaller than or equal to right, and top is smaller than or equal to bottom. As long as these 2 conditions hold, we'll just keep iterating through and fill out on this entire n by n square, square matrix. Yes. And then, so we'll start from, we'll fill from the top left, then go to the right. So int, that means we'll go column by column. So we'll use j to indicate the column as just a convention to reduce confusion. And then int j starting from 0. J is smaller than or equal to right boundary. What we'll do is j++, and then we'll put that into, oh, we need one more variable. We'll just call it number. Number is starting from 1. So you see here, this number is starting from 1. All right, and then here that is top row. So column is J, and then it's just a number, or number do plus plus after that. So after this first for loop, where we are here. After the first for loop, we are at this side at 3 position, at the position of 3. Now we want to go towards the bottom, right? How do we go towards the bottom? We need to do top plus 1, right? So top is the first row, and then we need to go to the second row, right? So top plus 1, and then we go towards from the top right towards the top, towards the bottom right. So we're going down right now. We're going down this for loop. Down means row by row, so we'll use I. I starts from, actually, J should start from left. Yeah, J should not start from 0 because the left boundary keeps shrinking. That's the whole reason we have these 4 variables. So, and then I is going to start from top. And then I, as long as I is smaller than or equal to bottom, then we'll just keep incrementing I. And then matrix, I is the row and the right is the column. Then we'll just keep incrementing number. After this, after the second for loop, where we are here. Oops. We're here. We're at this 5's position. So at 5's position, what we need to do, we need to shift towards the left. So that means we're going to do right minus 1. So right here, the right boundary is at 2, so we need to decrement 2 by 1. So 2 to 1. So here. And then next step, we need to go from this position towards the left. Another for loop here. Int, that means column by column, so we'll use J starting from right, and then J is greater than or equal to left side, left boundary. And then J, we keep decrementing J. And matrix, then this is bottom. That's the row index. Then column index is J. So that is number plus plus. So at this moment where we are at this position. We're at J. From the 7th position, we need to move up. Then we need to decrement bottom index. Bottom decremented. Is that correct? Yeah, bottom decremented. Then we need to go up. Stand for the row by row, go up. So I starts from bottom, and then I greater than or equal to top. I keeps decrementing, and then this matrix is going to be I is the row index, column index is left, and then assign number to this matrix number, and then increment number again. At this point, where we are at this matrix, this spiral matrix, we are at 8 here. And then from this position, we need to move towards the right. So we finished one entire loop on 4 sides. So now we're starting the second loop again. So it's going from left towards the right. So at this point, we need to shift the left boundary towards the right, right? So from the left boundary is at 8 here towards the right, 8 to 9. So left boundary is to go up. That's it. These 4 loops, let me just have a quick double check. J starts from left, smaller than right, keeps going up. That's the top row, and top incrementing, and then we start I from top. As long as top is smaller than bottom, I keeps going up, and then that's the right boundary, that's correct. And then right is going to shift towards left. Then we start from J from the right, and then as long as J is greater than or equal to left, J keeps decrementing. That's the bottom, that's correct. bottom row. Is that correct? Yeah, I think so. And then from the bottom, I starts from the bottom. As long as I is greater than or equal to top, I keeps going down. So, and that's on the left side. So I think that's correct. And then we'll just return the matrix. Let's hit submit and see. Cannot find symbol, number, matrix. Oh, shoot, variable number. Well, this should be matrix. Matrix. Let's submit. Oh, exactly. 8.33 memory. That's very low. Let's submit it again. The same. Okay, never mind. But basically, this is the idea of the follow-up question spiral matrix 2. Again, this is a common technique, very general, that we can apply to similar problems. We use 4 variables to control the 4 sides, the 4 boundaries, and we keep shrinking towards the middle. So in the four for loops, and then there is an outer while loop to control the exit, the break condition. That's it for this problem. I hope you guys. I hope this video could help to help people understand the solution of this problem and how to tackle it. If you have any comments, questions, please leave me down in the comment section below. And if you like this video, please do me a favor and gently tap the like button. That's going to help a lot with the YouTube algorithm. And also, don't forget to subscribe to my channel. I would really appreciate it. Thank you very much. I'll see you guys in the next video.